in the radical functions, what we're going to focus on are graphing square root and cube root functions. There's going to be transformations, but remember, we've been working on transformations all year, so at my last hour, it came back pretty naturally to them. So I feel like you guys are going to have the same process. And then we're also going to focus on identifying the domain and the range, which we've also been working on that lately. So I feel like that's going pretty well. With the square root, we're going to talk about the parent function first and the shape. Do you guys have everything you need from this page? Okay. Alright, so the square root function, we're going to start with the parent function. Okay, so the parent function for the square root is f of x equals the square root of x. So we've actually mentioned that in chapter 1 and did some transformations with that as well. When you have a parent function, it's helpful to look at the table. Now remember, we are doing this without a calculator. So if we're doing the square root, let's think about what are some good values to plug in. Do you guys know the first perfect square in the sequence? Nope, but all of what you said is ones we are going to put on there. So we are going to have 1, we are going to have 4, but there's 1 in front of 1. Yeah, 0, good. Okay, so 0 is the first one. Okay, the way you can find the first part here is you can take what's underneath the radical, set it equal to 0. So if you have x equals 0, then you're going to start there. Now, once you know what your x's are, to find y, you just have to do what? Yeah, just plug them in, right? So the square root of 0, the square root of 1, the square root of 4, the square root of 9. And the reason why we chose those is so when you take the square root, okay, you have your y value. So the square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. And the square root of 9 is 3. Okay, so we are going to graph these. Now, whenever we do a square root function on our homework, just like we have on here, what you're going to do is you're going to make sure that you have 4 key points. Okay, so for square root functions, I want 4 key points on your table. Okay, and you're going to be using graph paper. So not all the squares printed nicely, so we may have to squint our way through it. Okay, so I have to go out to 9 on my x. My y's only have to go up to 3. We'll plot these together, and then we'll talk about the shape. Because they didn't show up so well, I am going to label them to make that a little bit easier. Alright, so when we graph it, I'm going to start at 0, 0, so that's my first point. My second point is 1, 1, and then 4, 2, 9, 3. Okay, and then we'll connect it together. So when you connect this, you want to connect it with a curve. So you're going to start at 0, 0. And we are going to curve this to the right. I want you to notice something. I put an arrow on this end, not on this end. Do you guys know why? Yeah, Dylan? Yeah, then that's when we get into our imaginary, right? So if you do the square root of the negative numbers, you aren't going to get any real values here, so you can't go further on the x-axis. But the next perfect square after 9 is 16, I could be graphing more in this direction. So you're only going to have one arrow for these. Okay? Only one arrow. Alright? So again, that's because you can't take the square root of a negative. Now that's also going to relate to our domain. Because our domain is the set of our what values? Yep, our x values, which are our input. Okay, so the domain or the input are the x values. And then as we do different transformations, this is going to shift as well, so keep that in mind. The range is our output, which are our y values. So when we're thinking about the domain, one of the things we talked about is whatever is underneath the radical has to be positive. Do you guys remember what we call that value underneath the radical? Yeah. Yeah, good. Okay, so you can always take your radicand and set that greater than or equal to 0. Okay, and that's because you can't square root negatives. Okay, and then so your domain is going to be all values of x such that, can you guys finish it for me? How can I say that it's positive? Great. X is greater than or equal to 0. Okay, so you can take the square root of negative numbers. In this case, your radicand is x. So x is greater than 0. That's what we're going to put in the domain. Okay, now when you're thinking of the range is going to be the y values. So you want to look at your lowest and highest y value. In this case, what is your lowest y value? 0. Okay, and then what is your highest y value? Infinity, right? So your lowest y value is 0. The highest, positive infinity. Okay, so if it's going to positive infinity, you're going to have a greater than or equal to sign. And then your lowest value is 0, so it's just going to be all the y values have to be greater than or equal to 0. Okay, so it's 0 and above, so y is greater than or equal to 0. Okay, any questions for me about the parent function? Mm-hmm.
Is it for the domain and range always like that? Do they always look like that?
Always for this function, but we are going to be doing some transformations. So we're going to see how the transformations affect the domain and range. But parent function, yes, this will always be like that. Okay, now we're going to look at the cube root. Oh, actually, before we do that, does this shape look familiar at all? Look like anything to you? It just kind of looks like that. What if I do this? Yeah, it's part of a parabola, right? If I could, you could have the other side here. Why do you guys think it's related to a parabola? The parabola comes from what? From what? X squared, right? Yeah, the quadratic equation. And the quadratic parent function is x squared, right? What's the relationship between x squared and the square root of x? They're the inverses of each other, exactly. Yep. Because if you were to take the square root, you would get that. Okay? Alright, so the cube root is f of x equals the cube root of x. Okay, and now what we're going to do is we're going to think of the perfect cubes. So we're just coming off of something where you had to think about some of the perfect cubes. Remember some of those guys? Yeah, that'll be a high one. So we, but that is good. Yep, another high one. Let's start with one of the lower ones. 8. Okay. What's another one? No, go lower. 1. Yep, you can take the cube root of 0. Now, notice how I put them here. That's because, remember, you can take the cube root of what kinds of numbers? Negative. So we're also going to put in -8 and -1. You guys did a good job remembering those perfect cubes. That's great. Okay, so for the square root, we're having 4 key points. For this one, we're going to have how many?
5.
Yes. So the reason why we're going to have 5 key points for this one is because that's going to help you make the perfect shape, which we will look at in just a moment. So again, to find the y, you're just plugging this in. So you're taking the cube root of -8. You're taking the cube root of -1. Cube root of 0. Cube root of 1. Cube root of 8. Okay, so then let's find what those values are. And then we'll graph them. Okay, so when you take the cube root of -8, what do you get? -2. -1. 0. 1. 2. Okay, so now we are going to graph these. We just got to label our x and our y. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, so my scale for both of them is 1, and then we're going to go ahead and graph this. Okay, so I'm going to start at my 0, 0, and then I do my 1, 1, my 2, -1, -1, -8, -2. And I'm going to show you how to connect these so that they have a nice looking shape. So in a similar way that we did the square root, if you just connect these first with that curve, that sunrise, I like how you guys describe that. Okay, and then sometimes I even just turn my paper to do this curve. Okay, so it's kind of, this kind of looks like what? Like, how would you describe this shape? Yeah, it looks like a really stretched out S, right? Okay, and then when you turn it on its side, this is the graph of what? What type of function? A cubic function. Okay, it's actually the reflection of your parent function. Okay. Now, remember how we talked about the inverse relationship here? It's the same thing with this. It's an inverse relationship. You don't have to write this down. I just want to show you something from what we've done before. So this is what we just graphed, right? This is your cubic function, that x to the 3rd power. And then remember, this line, y equals x. Do you guys remember what that tells you? It's a line of reflection for your inverses. Okay, so see how this here mirrors this part here? Okay, so it is symmetric here. That's the reflection. Okay, and then the reason why they have that, again, is because they're inverses, just like the other one. Okay? All right, you guys ready to do the domain and the range? This one's a little bit different because your domain, your input values, this is a cube root. If it's a cube root, you can plug in negatives. You can plug in 0. You can plug in anything. So what would our domain be? All real numbers, right? So for any odd root, remember, there's no restrictions there. Even roots have restrictions, odd roots do not. Okay, and that's because you can multiply an odd number to get a negative. So if there are no restrictions, we say x, all values of x, such that x is an element in the set of real numbers. And then again, the range is about the y values. So if you look at your graph, this is going to slowly and slowly go to positive infinity, but this is going to slowly approach what? Negative infinity. So if the lowest y is negative infinity and the highest y value is positive infinity, what's the range going to be? All real numbers. Okay, so eventually if that kept going, it's going to keep scanning. Okay, so for the cubic function, all real numbers for the range and all real numbers for the domain. Mm-hmm. Yep, for an even root, you can't take an even root of a negative, and so that's why your domain is different from your square root.
Okay.
Yep. Okay, so now we're gonna perform those transformations I was talking about. So we're gonna be using the parent functions that we just graphed, and then there are kind of a lot of directions in this section. It says to describe the transformations. You have to graph the function, and then identify the domain and range. Okay, so the transformations, those are all of the things we've been working on this year. We've done transformations in really every single chapter. This is the first time we're seeing it in chapter 5. Okay, so the same rules are going to apply. Now when you graph the function, okay, to do that, I want you to use a table. So this is the same thing that you'll do in your homework. And then when you're using the table, if it's the square root, how many points should you have in your table? 4. And then for the cube root, that's the 5. Okay, so you need the 5 to get the stretched out S. Okay, and then we're going to identify the domain and range, and just like we did in the last section, we're going to be writing that in a special notation. Can you guys tell me what it's called? Yes, set builder. Yes. Okay, so domain and range, we're going to write that in set builder notation. And this notation is what you'll be using in pre-calc, okay, for most, if not all of the time. All right, so the first one, we're going to describe the transformations. That's the first thing. I want you guys to talk with your row. I want you to see if you can come up with the transformation based on what we've done before. Okay, so talk to your row.
The parent function is the standard vector.
What did you guys agree on? Yeah, so this is a horizontal translation. Horizontal translation. 3 units. To the right. Okay, now again, remember, if it's underneath the radical, okay, that -3, it's just like when you have it in parentheses, right? It's the opposite of what you see. It's the x minus your h value, okay? Now, you're going to have several different types of transformations on your homework, so we're just going to write down a general rule to help you remember. anytime you have something that is under the radical, okay, if it's under the radical, it is going to be a horizontal transformation. And yes, we're saying transformation, not translation, because that could include going left or right, a translation, but it could also include what? What are the other types of transformations? Yeah, the stretching, the compressing, and yeah, so the other type is going to be if it's outside of the radical. If it's outside the radical, that's when you have a vertical transformation. So that's going to be your up and down. Okay, that's going to be the stretch and compression if it's outside. Okay, and then besides the horizontal and vertical transformations, do you guys remember there's one other type of transformation we talked about? Yeah, the reflections. Okay, good. All right, so what we're going to do is we're going to use our parent function to help us transform this, okay? So the parent function is exactly what we did on the first page, okay? So your parent function is the square root of x. Sometimes people will ask me, oh, do you have to memorize this? You're probably naturally going to memorize it, but no, you don't have to memorize it. You just have to know what your first four perfect squares are. What are your first four perfect squares? 0, 1, 4, 9. As long as you know that, you can plug it in, right? Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Okay, now we're going to think about how can I transform it. So if it's a horizontal translation, 3 units to the right, what does that mean? What does that mean? What would I be doing to the parent function? What are you guys thinking? Yeah, you're going to add 3 to the x value. Okay, so if it's a horizontal translation, 3 units to the right, that means you add 3 to your x values. Okay, so we just have to do the x values plus 3. That's going to create our new table. Okay, so we're just going to be adding 3 to our x's. Okay, so 0 plus 3 is 3, 1 plus 3 is 4, 4 plus 3 is 7, 3 plus 9 is 12. And that's the only transformation, which means you're only going to be transforming the x's. The y's are going to stay the same. So this is 0, 1, 2, and 3. All right, so you guys ready to graph this now? Okay, so let's set up our x and y. So now look at your x's. So I have to go out to 12, so I'll keep that in mind. Your y's, you only have to go up to 3. So this is like when you're doing it on graph paper. Sorry, not all of the lines printed very nicely. Okay, and then it helps me to label when I'm graphing. And then at least put something on them, on each one so we know what our scale is. Alright, so I have 3, 0. You guys go ahead and graph on yours. 4, 1, 7, 2, and 12, 3. Now you know what the shape of this should look like. Okay, so if you have a point that's out of line, If you're not able to make this nice curve, then I would go back and just check your math. Make sure you got the right points there. Okay, and this really is half of a sideways parabola. All right, so now that we've done that, we have to think about the domain and range. I showed you how to graph this with the parent function. Another thing that you could do is you could think about what values would give you a perfect square. I think you're going to like this way better, but you do want to make sure that you have the starting point, and a good way to do that is to take your radicand and set it equal to 0. Okay, so if you take the radicand and set it equal to 0, you have x minus 3 equals 0, so x equals 3. This is where your table should start. Okay, so this is where you should have your starting point. Now, if you wanted to just start there, that's fine. And then you could plug in different values to get the perfect squares. Because whatever's underneath the radical, you want it to be a perfect square if you're doing this without a calculator. Okay, so the values that you want underneath are always going to be your perfect square values. So if you have x, see how I set x minus 3 equal to 0? That's what you want for the first one. The second one, you'd want x minus 3 equal to 1. Then you'd want it equal to 4. Then you'd want it equal to 9. Well, in order to get the new points, what would you do for all of these? Add 3, which is exactly what we did for the table, and that's why I just recommend using the parent function and doing the transformation. Do you guys have questions for me about using the parent function and then doing the transformation for part A? Okay. Do you guys think you could do the domain? Okay, so the domain is connected to the radicand. So we know that we can't take the square root of what kind of numbers? Negative, right? Okay, now you can't use the same domain as before because it was 0 and above. What happens if I plug in 0? What do I get? I get negative 3. You can't take the square root of that. So just like this had to shift, okay, our graph shifted, so is your domain. Where is it going to start this time? Yes. So again, you take that, you set it greater than or equal to 0. Okay, so that's your radicand. It's greater than or equal to 0. Just add it over. So your domain is x, such that x has to be greater than or equal to 3. Okay, and then your range, remember your range is your y value. So what's your lowest y value? 0. Okay, so the lowest y is 0. The highest y is infinity. Okay, so it's y such that y is greater than or equal to 0. This stayed the same. Why didn't this one change?
Because there's no transformation.
What type of transformation? Vertical, right? There was no up or down. So the vertical would change the y values. We only change the x values. Okay? Those are all connected together. All right, why don't you guys start part B? So I want you to start by writing out the 2 different transformations, and then we'll talk about how those are connected to the graph. Okay, you can check in with your row for the transformations. You guys so confident you don't want to check in with your row? Doing good? 2 transformations, so make sure you get both of them. Okay, Danny, tell me what you got. What did you guys come up with? Good. Keep going. So vertical stretch by a factor of? Good. Great. All right. So vertical stretch by a factor of 2. And then a horizontal translation. Right. Okay, so this is our first thing here. All right, now if it's a vertical stretch by a factor of 2, can anybody tell me how that's going to affect the parent function? What are we going to do? Yeah, good. Okay, so you're going to multiply your y values by 2. Great. You guys remember this from earlier? And then we just did the horizontal translation, so this is the same thing, where you're going to add 2 to the x values. Now this one is a cube root. Okay, so we're going to put our 5 special points on there. -8, -1, 0, 1, 8. Okay, and then we have -2, -1, 0, 1, 2. Alright, and then this one is called g of x. So, let's go ahead and apply our transformations. So if we're multiplying the y values by 2, everything here gets doubled. So if I double -2, what do I get? -4, double -1 to get -2. 0 times 2 is 0, and then I have my positive values. Okay, so I times by 2, and then here I'm just going to add 2, and that's going to give me my y's, or my x's, sorry. Okay, so I have -6, -1 plus 2 is 1, 0 plus 2 is 2, 1 plus 2 is 3, 8 plus 2 is 10. And then once you have your table set up and ready to go, you are ready to graph. Yeah, not all these lines turned out so great, so I'm going to put these little dashes to help me. You guys might have better eyesight than I do. Oh, I thought you said I do. I forgot. Yeah. I know, that's all good. Just wait. Alright, now again, remember when you graph this, it should be like an S shape, but because you have a vertical stretch, it will look a little bit different than the parent function, but the shape is still the same. Okay, so I have -6, -4, -2, choose 0, 82. Okay, and then once you have your points, again, I always do this one part at a time. So I make the top part, and then I do the bottom. I find that just gives me a better shape. I have that stretched out S shape. Okay, did you guys remember that you got to do your domain and range as well? Okay, so again, this is a cube root, so even though we applied some transformations, are there any restrictions? No, there's still not any restrictions. So your domain is still all real numbers. Same thing with the range. See how your highest y value is going to be infinity because that's going to keep going. Okay, this one's going to keep going. So where transformations are going to affect a square root function, it is not going to affect the domain and range of the cube root function. Okay, so there's still going to be no restrictions. So when you're doing the cube function, your domain and range should always be all real numbers. Okay, you have 2 arrows here, just 1 arrow on this one. All right, questions for me on that one? You guys ready to try the last one? Okay. So again, I want you to start with identifying those transformations, and then we can talk about how to apply them to your parent function. See if you can write out your table. Okay, and this +1 is not inside the radical, so make sure that you write that accordingly. There's 3 transformations. And something that I use to help me is I really just go in order and I look at whatever is added. So this negative in front, do you guys know what type of transformation that's going to be? Yeah, do you guys remember what the reflection is over in particular? Yeah, good. Is there a way that you guys remember that? Yeah, y inside, y not. Yeah. Somebody said you got a 50-50 chance. Yeah, but you want to get it right? The XO, the X goes on the outside. Okay. That's right. Reflection over the x-axis. Okay, good. Then I have this -4, right? So set that -4 inside. Can you tell me what transformation that will be?
Horizontal translation
4 units, but yes. Yep, horizontal translation. Great. 4 units right. All right, and then Dylan, you want to tell me what the last one's going to be? Good. Vertical translation, 1 unit up. So that's outside, so it'll be vertical. Great. Okay, now let's talk about how these are going to affect our table and our graph. Okay, so the reflection, actually, we'll save that one. How about, let's do the horizontal translation first, because I feel like you guys got that. We've done that several times. So the horizontal translation, 4 units right, means we're just going to do what? Add 4 to the x. Okay, the vertical translation, 1 unit up, what do we have to do? Add 1 where? Yep, add 1 to the y values. Okay, now the first one is kind of tricky. You guys think you know what to do? You're really, really close. So you are gonna multiply by -1, and look and see where this is. See how it's on the outside. So what type of transformations are on the outside of the radical? Vertical, right? And if it's something that's vertical, we apply it to the y. So this is going to be multiplying the y coordinates by -1. And again, a good way to remember that is that it's on the outside, which means it is going to affect the graph vertically, and so that means it's going to affect the y. The other thing that we talked about is when you have a reflection, okay, the reflection, it's the opposite of the other coordinate, okay? So if it's a reflection over the x-axis, it's the opposite of your y, which is the same thing as multiplying it by -1. That's something that you did in geometry, which I know feels like a long time ago. So if it's a reflection over the y-axis, it's the x that's affected, and then vice versa. Yeah?
What's the order of operations?
Okay, so you used a good phrase. So the order of operations, right? So there are two things that you're applying to the y. You have to do the multiplication, and then you have to do addition. So according to the order of operations, what should you do first? Multiply before you add. So that's exactly what we're going to do. Okay, so let's take the parent function. Okay, which for this is the square root of x. Go ahead and write that down. I'll give you a chance to do it before I do the parent function. Yeah. So the parent function for square root of x starts at. And really, when you're doing the parent function, you're just listing the perfect squares, right? The first perfect squares, and then taking the square root. Okay, and then the x's, you're just going to be adding 4 to it. This is h of x. Okay, so for the x's, you're just adding 4. So 0 plus 4, 4. Plus 4, 5. Plus 4, 8. Plus 4, 13. Okay, now for these, order of operations, you're going to do the multiplying, or think of it as the opposite first. Then you do the adding. And if you want to write it out, you can. If you do the opposite of 0 is still 0, because it's not positive or negative. Opposite of 1 is -1. Opposite of 2 is -2. Opposite of 3 is -3. Then you can do the plus 1. So plus 1 is 1. -1 plus 1 is 0. -2 plus 1 is -1. And this would be -2. Okay, so if you want to write that out, if that helps you, great. If you can do both of those in your head and you just want to write it on your table, that's fine too. Okay, so you choose what works best for you. Okay, so we did both of those to get our y's. And now we are ready to graph. Okay, so we're going to do our y's and our x's. So my x's have to go to 13. Alright, and then we're going to plot our points. So we have 4, 1, we have 5, 0, we have 8, -1, and we have 13, -2. So remember, we had a reflection in there. So instead of it going up from left to right, okay, the curve is just flipped. Okay, so your curve is going this way. Okay, so keep that in mind when you're thinking about your domain and range. Remember, the domain is always about the radicand. So the domain, you'll always take the radicand and set that greater than or equal to 0. It doesn't matter what's happening outside. It's inside the radical that matters because you can't take the square root of a negative. So if you have x minus 4 is greater than or equal to 0, that means x is greater than or equal to 4. So your domain is x such that x is greater than or equal to 4. Okay, so for the domain, you always take the radicand, you set that greater than or equal to 0 because it needs to be positive. For the range, we've been identifying the lowest and the highest y values. Okay, so in this case, what is the lowest y value? No? But that is the what? The one is one the lowest or the highest? The highest one. The lowest is negative infinity. Okay, so now that the lowest is an infinity, that means the sign is going to flip. So it'll be y such that y has to be less than or equal to 1. Okay, and then if you notice, we've been talking about how in the first one, we talked about the starting point. I am going to put it back there. I just want to show you this. We talked about the starting point, right, with where the starting point should be at 3, and then that's going to be related to your domain. But look at your range. Look at what the output is. That is related to your range. Same thing with this one. Okay, that is related. Okay. All right. So I'm going to give you some time to get started on this. So for your homework, make sure that you're doing these 3 steps. You're describing the transformations, you have your domain and range, and then you have to have those specific points, the 4 and the 5. And then this is a no calculator section. Okay? And then next week, we will be testing over chapter 5, but there is going to be a special emphasis on the sections we're finishing this week, which is 5-7 and 5-8. Okay, so this is a really good time if you've been not doing all your homework to get back into it. You can see there's not a whole lot of problems for this because it's the graphing. There's graphing. I tend to give you less because I know that's more intensive. Okay, and you do need to put this on graph paper. I put some at the front, so if you need some graph paper, you can help yourself. And if that runs out, let me know. I have more.